In this video, we're going to do a few more problems for Lewis structures. So let's do some examples from number 4 over here. We'll start with 4A. So actually, we've done H2S in the previous video, so we won't do A. Let's actually do, and we did CCl4 in the lesson, so we can skip that. Let's do NCl3. So we'll start at C. So NCl3. There's 5 valence electrons from the nitrogen, and then 7 times 3, 21 from the chlorines. That's 26 total electrons to place. So let's go ahead and do that. We'll start placing our central atom, which is the one with the fewest, so nitrogen. And then we'll place the peripheral atoms with single bonds. Having placed those single bonds, we've placed 6 electrons because each single bond counts as 2 electrons. So that's 20 left to place. And so we're going to go with 1, 2, 3, 4, 5, 6 around the peripheral first. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. They all have their octet. They're happy. We have 2 more to place, and we can go and put that on our nitrogen right up here. And so it's 20 electrons placed. So minus 20, that's 0. We're all done, and everything's happy with our full valence shells. And so that's the nitrogen trichloride. We can go ahead and try the SO4 example, D. So D is SO4, 2 minus. And so here we have 6 valence electrons from sulfur plus 6 times 4, 24 from oxygen plus 2 from the 2 minus there. And that'll give us 32, like that. And so now what we need to do is we need to go ahead and put our central atom and connect our peripheral atoms surrounding it, of course. And so having done that, we've placed 8 electrons because there's 4 bonds there. So that's 24 electrons left to place. And we can go ahead and put those dots around our oxygens. And what you'll notice is that we'll essentially have used up all the electrons and everything will be happy. And we can put our charge square brackets around it, but keep in mind this is a 2 minus molecule. So typically in a 2 minus molecule, what that means is that 2 of the oxygens are single bonded and the other ones are double bonded. So we can just choose any 2 to make them double bonded to the sulfur. And sulfur can handle it because it has a stable, it has an expanded octet since it's in period 3. So you have to make sure that it's in period 3 if you're doing this. And then don't forget to put back your remaining structures and then put your 2 minus. You could have chosen 2 other oxygens to have as double bonds instead. It doesn't really matter which ones you chose because they're equivalent structures. And like I said, you'll learn more about that in grade 12, but they would be equivalent structures nonetheless. Let's go ahead and try NO2 minus. So it's NO2 minus. So we have 5 from the nitrogen plus 12 from the 2 oxygens plus 1 from the minus. Gives you 18 to place. And so we'll go ahead and do that. Place our central atom as a nitrogen. And we'll we had placed 2 single bonds, so that's 4 electrons. So 14 electrons left to place. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we placed 14, there's 0 left. Everything looks happy except for the nitrogen. It's missing 2 electrons. So we can make one of the oxygens decide to share. And we get NO 1, 2, 3, 4, 5, 6, 7, 8, double bond, like that. And so our oxygens are happy and our nitrogens are happy now. And don't forget to put your charge of -1. And let's try the Lewis structure for carbon monoxide. So let me just hide or delete the ink, and we'll go back up and do some more work up there. So again, you should be trying these out yourself before you check my answer. So carbon monoxide, we have 4 valence electrons from carbon, 6 from oxygen, is 10 electrons a place. Let's go ahead and connect our atoms together. There's no central atom here. So we have 10 minus 2 because of that bond there. That's 8 electrons left to place. So we go 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is happy, but carbon is not. So maybe oxygen can help it out by adding some of its electrons to that pool there. And so now we'll get double bond. Carbon is still not happy, so maybe oxygen can help a little bit more, and we get a triple bond for our carbon monoxide. And then we'll try PO4 3 minus. So for the PO4 3 minus, we have, let's write this out here, PO4 3 minus, so 5 electrons from the 5 valence electrons from the P. 4 times 6 is 24 from the oxygens, plus 3 from the negative charge there. So that would be 32. And then we can place our oxygens around the phosphorus there. And so what we've done is we've placed 8 electrons, so there's 24 left to place. And we can place those 24 around the oxygens that are there. And we can put a 3 minus charge, but keep in mind this is a polyatomic ion with a 3 minus charge. So what that means is that three of the oxygens are single bonded, and 1 is double bonded. So it doesn't matter which one. Let's just choose the top one to make it double bonded here. And so a better structure would be, so this would be 3 minus, but we're making a better structure. We have P double bond O, like that. This, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And we have our 3 minus, and this is our phosphate polyatomic ion. And so there's all the examples for question 4. Now we'll try the examples in question 12. So we'll try the Lewis dot structure for Cl F3. So you can pause the video and try it yourself. So we have Cl F3. And so we have 7 valence electrons from chlorine, plus 21 from fluorine, because there's 3 of them. That's 28. So central atom is fluorine. Let's put it's chlorine. Let's put our fluorines around it. And so we have 28 minus 6, and that's 22. And so we can start filling out our peripheral atoms. So far to fill those out, we have placed 18. They're all happy. And we can place 4 more electrons. So let's do 1, 2, 3, 4 there. And that's 22 electrons placed at 0. So our fluorines are all happy. They have 8 and 8. Our chlorine has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is okay. This does work out. It just happens to be one of the expanded octets. Let's go ahead and try SCl4. BSCl4. 6 valence electrons from sulfur. Then 4 times 7, 28 from chlorine. Gives you 34 electrons total. Let's go ahead and put our central atom as sulfur and connect the 4 chlorines to the sulfur like this. And so what we've done is we've placed 8 electrons. And so there's 22 electrons left to place. We can place them around our chlorines. So, nope, that's not 22 electrons left to place. That would be 26 electrons left to place. So we can put our chlorines there like this. So our chlorines are all happy. We've done that. We placed 24 total so far because we have 6 times 4, 24. But we still have 2 more to place, so we can do that on our sulfur. And put them in as pairs there. And this is another example of an expanded octet. So we have another expanded octet in this example here. And we'll do our last example, which is the PF5. So PF5. So we have 5 valence electrons from phosphorus, and then 7 times 5 plus 35 from fluorine. That's 40 total electrons a place. So let's go ahead and do that. We'll put P in the middle, and then the F's will be the peripheral atoms, like that. And so we placed 5 bonds, so that's 40 minus 10, that's 30 electrons left to place. So we can start by putting our peripheral atoms first. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And what you may have noticed is that we have put 1, 2, 3, 4, 5, 30 electrons. So there's 0 left to place. So we're all done. The phosphorus is happy, more than happy. It has its expanded octet because it's in the third period, and that's okay. That works out as well. So those were some extension questions where we had the expanded octets that were included as well.